So hello everybody, we're going to talk a bit about Jenkins X, so let's get going. We've got 45 minutes and then we can have a beverage. So hopefully this won't take too long. So the first thing I want to talk about before we get going is the Accelerate book. How many people have read the Accelerate book already? Anybody read the Accelerate book? A couple of people? If you've not read it yet, please buy this book, it's awesome. Nicole, one of the authors, is speaking tomorrow at 11. This is one of the most impressive books on DevOps there's, I think, ever been, or at least in the last decade. It's a stunningly impressive book that really, it's based on the state of DevOps research that's been surveying DevOps folks for probably 4 or 5 years now, and trying to find out what are the best practices of high-performing teams. So what is it that high-performing teams are doing that makes them so high-performing? And the results of this survey and the results in the book are really pretty stunning. Like, I think we've all heard the phrase 10x developer, like, are really some developers 10 times better than other developers? And there's lots of heated debates if that's really even a thing. The State of DevOps report has found that some teams are 2,000 times faster at delivering value. I mean, just think about that for a second. There could be a team out there that is 2,000 times faster at getting a feature out in terms of customers, right? That's a scary multiplier, 2,000 times. And what they've also found is it's not just about going fast. You can go really, really fast delivering value, but you can also have less bugs and have a quicker failure recovery rate, right? So it's not just that these high-performing teams are going really, really fast and breaking everything. Really high-performing teams have figured out how to deliver software value quickly while delivering higher quality software with less bugs, less issues. And if ever there is an issue, they fix the issues faster. Right? So it's faster in every possible way. So this is truly amazing and also kind of shocking and scary, right? If you're in a low-performing team and company and your competitor is high-performing, it's not going to take them long if they're 2,000 times faster to kind of have more value than your business. So low-performing teams are going to be out of business pretty quickly. So I think all of us as DevOps people, we need to up our game and we need to all become high-performing teams. Now, one of the lovely bits about the book, please go see Nicole's talk tomorrow. I'm not trying to steal her slides or thunder, but one of the lovely things about the book is it makes it clear anyone can be a high-performing team, right? Any teams can learn the good behavior and the good habits to become a high-performing team. So there's a whole bunch of different things in the book, and I won't quote the book right now, but for me, some of the big 3 things are automating CI and CD, and using the cloud well. Those are scientifically proven, if you like, to be high-performing teams' best practices. There's a whole bunch of different things in the book that are really interesting, like, for example, the use of the long-term use of feature branches is seen as something that high performers don't do. High-performing teams tend to use trunk-based development. In other words, keeping the trunk, the master branch or the trunk, clean at all times and release constantly from master, and have very short-lived branches for pull requests and release from master and keep master golden and ready to release. And one of the things we've been doing with Jenkins X is really trying to look at how can we help teams become high-performing teams. So we've been through the book in very graphic detail, and we've tried to figure out what are those behaviors in the book that we can automate through software. Now, just to be completely clear, lots of things in the book are not really automatable by software. They're things like how teams should work, management structure, and culture, and so forth. So there's lots of things tools can't help with, but there's a huge amount in the book that tools can totally help with. We can automate CI and CD, so you don't waste time setting up CI and CD. We can enforce or encourage trunk-based development. And we can make it easy for you to use the cloud well. Let me talk a little bit about the cloud, because this is kind of important as well. In 2018, like this year, Kubernetes is officially won as the API, the platform for developing for the cloud, right? Today, you can run Kubernetes on your laptop, on-premise, in your internal data center. You can run it on every public, private, and hybrid cloud. You can run it on every operating system vendor's platform, you know, OpenShift and Ubuntu. You can run it on every PaaS, right? Pivotal supports Kubernetes, VMware supports Kubernetes, Cisco supports Kubernetes, IBM Cloud supports Kubernetes, Oracle Cloud supports Kubernetes. The IT world has been fragmented for many years, and we've had a gazillion programming languages, a gazillion operating systems, and the whole IT world has seemed to be fragmenting. Every year it seems to get more and more diverse. There's another programming language or JavaScript framework or whatever every year. But the first time ever in our ecosystem, the entire business and ecosystem is standardized around Kubernetes, right? So if you develop for Kubernetes now, you can move your application to any cloud, right? You're not locked into Amazon, you're not locked into Google, you're not locked into Red Hat. You can build an application today, package an application up as a Docker image, make some Kubernetes YAML, which is the metadata you use to deploy it, and then you can literally take that application and run it anywhere. On-premise, public cloud, private cloud, hybrid cloud. That's kind of a truly amazing thing when you think about it. We've had these wars, OpenStack versus Amazon versus EC2 APIs versus all this kind of mess. We've had this big, huge mess of doing continuous delivery for years. Now we have a very simple future of, well, it's still kind of complicated, but at least we have a single future to worry about, Kubernetes, right? Kubernetes is the API platform for deploying applications on the cloud, right? It works on-premise, it works on the public cloud, and you can install it anywhere. So Kubernetes is awesome. I don't know if you've noticed, I like it. It's really, really awesome. One thing about Kubernetes, though, friends don't let friends install Kubernetes. It's a kind of a beast to install and manage. And these days, one of the things about using the cloud well is outsource stuff to cloud providers when it makes sense, and you can do so. So I hugely recommend, if you're going to even look at Kubernetes, outsource the management of Kubernetes to a cloud provider. So all of the big cloud providers, Amazon, Google, Microsoft, DigitalOcean, and Alibaba, and various others, they all offer a managed Kubernetes offering, which basically means you open a web page, click a button, and you get a Kubernetes cluster. You don't have to figure out how to install it. You don't need to figure out the DNS and the load balancer and the networking stuff and the storage. You click a button and you get a Kubernetes cluster. But the more important thing is the managed service providers will manage it for you. If a node dies, another node gets created. If the master goes down, it gets restarted for you. Some of the cloud providers can do things like automatic rolling upgrades of software versions as Kubernetes goes from version like 1.10 to 1.11 to 1.12. They can do automatic patching of the operating system for you. So use a managed cloud provider. It just saves you loads of time and loads of pain. And they're all pretty good. I mean, Amazon, Google, and Microsoft all have really good services right now. Amazon Service EKS is a little bit behind where Google are and Azure is. My personal favorite right now is Google. Google's GKE is truly awesome to use. It's awesome. But you know, Amazon's catching up fast with EKS. Azure has AKS, which is really powerful and really good. Another interesting thing about Kubernetes is a lot of people say, well, I can't really use Kubernetes because I'm on-premise and I have to use data centers in some location or whatever. There's a whole bunch of vendors out there that can do on-premise installations. You know, there's Red Hat with OpenShift. There's various other businesses, Pivotal with PKS, VMware with VKS, I think it is. Another thing that's really interesting is this year, Google announced GKE on-premise, which basically means you can have Google Cloud on your machines in your data center managed by Google. Azure has had something called Azure Stack for about a year or so. I don't know when this is happening. I think it's this year, but at some point Azure Stack is going to include a managed Kubernetes offering. So Microsoft and Google will do a managed cloud on-premise and public cloud. So you can use the same UI to manage all of your Kubernetes clusters, whether they're on-premise or whether they're in the public cloud, and then you can just move workloads between the two as you see fit. So it's a really interesting time to be a developer right now, quite frankly. Kubernetes is amazing. It's never been easier to use and consume and work with. And none of these barriers of on-premise, public cloud, hybrid cloud, private cloud, none of those really matter. Just use whatever you can. If you can use the public cloud, please use it. It's the easiest thing to use. If you have to be on-premise, crack on. If you need a VPN, that's all fine too. So I mean, I'm kind of old, and I've been in the IT world quite a while. This is the most exciting time I think there's ever been in software, because when we finally have a single way we can build and deploy an application anywhere, and we can make the cloud easy to use, right? Before, the cloud used to be all this weird, crazy Amazon stuff and horrible shell scripts and all kinds of weird stuff. Now it's just simple, standard Kubernetes stuff, which is, once you get over the learning curve, it's actually pretty easy to use. Kubernetes is pretty much awesome. Okay, so I should talk about Jenkins X, shouldn't I? So Jenkins X is really trying to automate all of these best practices. So we're trying to automate your CI and CD, and we're trying to help improve your DevOps practices by automation. Because there is a standard Kubernetes, we can now actually do the D part, the continuous delivery part. For the last 30, 40 years, when you talk to any customer, any company, and you say, how do you deploy things? And they'd say, well. And there's normally a long story, and it's normally, there might be some Bash, there might be some Perl, there might be some PHP, there might be Chef, Puppet, Ansible, whatever. There's a whole raft of different tools that might be used in a hodgepodgey kind of way to do deployments. With Kubernetes, we can now deploy everything with one simple approach, Kubernetes. So that's really what Jenkins X is trying to do, is trying to automate CI and CD for Kubernetes. So we love Jenkins, but Jenkins X is taking a slightly different approach. We're looking at the problem of doing CI and CD and working backwards. If you spin up the Jenkins console right now and you click like the new pipeline button, you get a nice big blank page, which isn't that awesome. What's more awesome is automating the CI and CD for you, so you don't even have to look at a Jenkins file or a Docker file or Helm charts. You can just give Jenkins X your code, and it takes it from there. So let's dive into some details, and then I'll try to do a demo. So how does Jenkins X help? So the first thing Jenkins X does is it automates all of your tools and environments. So things like Jenkins, things like Nexus, things like Helm, Monocular, a chat museum, and various other pieces. So there's all sorts of bits of open source you need to plug together to do effective CI and CD. So Jenkins X automates all that stuff. If any of you have followed the Kubernetes ecosystem, there's a whole raft of open source projects out there, and it's quite a struggle keeping up with all the new innovations. So there's Helm, for example, is a package manager. Think of it as like Brew or Yum or RPMs or NPMs or whatever. It's a way of installing packages on Kubernetes and managing versions and rolling forwards and rolling back. But there's a whole bunch of other things. There's something from Google called Scaffold, which focuses on all the different ways you can make Docker images on a Kubernetes cluster. There's, a ton of other stuff too. So Jenkins X automates installing and configuring all the tools and all of your environments, like development environment, test environment, staging, production. It also automates all of your CI and CD pipelines. So you can literally just import Spring Boot app, Node.js, Go, whatever, and it will automatically do the CI and CD. So you don't have to sit there and scratch your head and read loads of blogs of what Jenkins files looks like. You can just automate your CI and CD, creating Docker images, deploying via Helm charts into Kubernetes, and doing all of the CI and CD. Another thing Jenkins X does for you is something called GitOps. So the basic idea behind GitOps is, actually, one of the high-performing teams' best practices is using source control. Now, I hope everyone uses source control in this room. If you don't, please see me after. You need help. I'll get the first beer in, because it's quite a scary thought to not use source control. But the idea behind GitOps is, let's use source control for doing promotions to environments. So I hope all of us like source control for managing code for our applications. The idea behind GitOps is, let's use a Git repository to manage all of the environment configurations and applications we wish to use in an environment. So for example, in production, if I have 3 apps, in a Git repository, in source code, I would say, what are the 3 applications, and what are the versions of those applications, and are there any environment-specific tweaks into those applications? Then to do promotions with GitOps, what we're really doing is a pull request on source control to change which apps are running, what versions to use, and so forth. Now, the reason this is awesome is everything is audited and versioned in Git. So if all of a sudden production goes pear-shaped, you can look at the Git log and see it was James, and James has done that thing again, and he's broken everything. So just revert James's change, and you're good to go, right? So it's nice and simple. One of the slightly scary things with any kind of cloud is, once you roll this out to lots of people and lots of teams, if you give all of your teams like SSH access, or the Kubernetes equivalent, kubectl access, or kubectl, you can just type kubectl apply this, or kubectl delete that, and all of a sudden stuff gets deleted, and nobody quite knows who did it, and why, and when. If you take away write access from your developers and put everything in Git, everyone can see what everyone is doing in a single audited place. So GitOps is a lovely approach for managing environments, and it helps the team work together and improves feedback. So that's kind of what Jenkins X does. How do we go around installing Jenkins X? So basically, Jenkins X just needs a Kubernetes cluster, and it installs really simply in one command. The first thing you need with Jenkins X is something called the JX binary. So JX for Jenkins X. So you need to download this binary. Then you need to either create a new cluster if you don't have one already, or install Jenkins X on your existing Kubernetes cluster. If you're trying this for the first time, our recommendation is that middle line on the slide, JX create cluster GKE. That will spin up a brand new Kubernetes cluster on Google Cloud, and then install Jenkins X on top of it. We also support all the other clouds, so instead of GKE, you can say AKS for Azure, EKS for Amazon, PKS for Pivotal Cloud. I can't remember what the IBM one is. There's an IBM one, and there's a VMware coming soon. If you have already a Kubernetes cluster, you can do the last line, JX install, and you can say which provider it is in case you want to do provider-specific tweaks. We try and configure Jenkins X to work slightly differently on different clouds. So, for example, if you're using Amazon, we will use Amazon's Elastic Container Registry by default for Docker images. Fairly soon, we'll be doing the same with the GKE version on Google Cloud and on Azure. So that's how to install it. That's nice and simple, a couple of commands. Here's a very quick screen. In fact, I won't even do that. Let's not worry about that. That's a screenshot of how to install it on Google. Let's crack on. So once we've done the JX create cluster GKE, or we've done the JX install, what does that give you? So that gives you, each team gets their own development environment where all the tools run. So that's where your Jenkins would run, your Nexus would run, and that's where all your builds happen. Each team also gets a staging environment and a production environment. Now, each team owns their own staging and their own production. So that means if you're trying to be a high-performing organization with lots of different teams, teams don't have to ask permission to be allowed to deploy anything. Teams can just crack on delivering value and going quickly. So you don't have to have lots and lots of meetings and get lots and lots of approval to be able to deploy something. What we do by default is the staging environment, we automatically promote to the staging environment, and we manually promote to production. What we'd really like is for everybody to always automate everything. So we kind of want you to automate all of the pipelines and go all the way to production. But we kind of think it's going to take a little while for most people to feel comfortable doing that. So we've left promoting to production as a manual step that you choose to do that when you're happy, and you automatically go to staging all the time. Each team, though, can create as many environments as they wish. You can call them whatever you like, and you can do automatic or manual promotion in each environment. So that's what it gives me. Now, how do you actually use it? So if you have some source code already, like you have, I don't know, a microservice in Java, some Node, some Go code, some PHP, Rails, Ruby, Swift, something, CD into the file system where the source code is and type JX import, and that will import the project into Jenkins X and automate the CI and CD. If you're starting a new application from scratch, you type JX create Quickstart, and that gives you a menu of different Quickstarts you can pick with different programming languages to use as a basis for your first version of your microservice. You can then iterate on it and do different things with it. If you're a Java person who likes Spring Boot, you can do JX create Spring and create a new Spring Boot application. So let's actually do some demos, and let's see if I can find a shell that's visible. Oh, okay. Let me try change the screen resolution, maybe. Oh, let me just make the shells really big. Let me try find my mouse pointer. Where's the mouse gone? I wasn't allowed to try out this screen. Let me zoom like that. This is very weird. Okay, talk amongst yourselves for a minute. I'm just going to use the command line. Command line rocks. Oh, okay, hang on. Right, let's make that bigger. Okay, here we go. So we have a command line called JX, and I can do things like JX get env, and this will give me a list of all the environments. If I'm on the Wi-Fi, I'm on the Wi-Fi, awesome. So these are all the environments I've got in my cluster right now. So this is all running live on GKE. So please don't download anything or torrent any files while I'm doing this demo. So I've got Kubernetes, a Kubernetes cluster in GKE. So I previously ran JX create cluster GKE. So I've got a GK cluster with Jenkins X installed. Bigger font. Yeah. OK. If only I could get my mouse back. Oh, it was there. Oh, this should help. I can even see it now. OK, thank you, Pete. That was awesome. Right, let me make this much bigger. Whoa. This is the highest res I've ever seen in my life. Right, OK. Right, OK, that's bigger. There we go. Right, OK. OK, we're rocking now. Let's crack on. So let's create a brand new application. Let's do a Spring Boot application. Lots of people use Java. Java's still really, really popular. So let's create a Spring Boot application. So JX create Spring. Now it's going to ask us which programming language we wish to use. So Groovy is obviously really groovy. But let's go with Java because it's a bit more common. And then we need to give it a group ID. We'll just use a default. And let's think of a funny and amusing project name. Jenkins World Beer. Just beer. Jenkins World Beer. Now it's going to ask us, what this is doing under the covers is it's using the Spring Boot initializer, or if you know start.spring.io, that website, it's using that to create a new Spring Boot application. So now it's asking us what dependencies do we wish to use in the Spring Boot application. So let's use actuator, let's add web, and that'll do. Now it's creating on my local file system the source code to the project, and then it's saying, do I want to use my Git username? Yes. Would I like some Git? Yes. Would I like a commit message? Yes. And now it should be creating a new GitHub repository. Yeah, that's my username. Let's put it there. And then JWB is a thing. And if GitHub works and the public cloud works, then this should hopefully make a GitHub repository. Awesome. Right, let me see if my browser's working. This could be interesting. Let's click on that. Oh, lovely. It's on a different screen. OK. So this is the... OK. So this is the Git repository. So what we've basically done is one command. We've created a brand new Spring Boot microservice. We've initialized a Git repository. We've pushed it up to GitHub. We've also then generated the CI and CD pipelines. And we've wired up a webhook on the GitHub repository. So whenever we do a Git push, it will trigger a CI and CD pipeline. OK, so one command, JX create Spring. You can also do JX import, and you can also do JX create Quickstart. So that was nice and easy. We just automated our CI and CD pipeline. Now if I can figure out how to get to the other screen. Oh, maybe I'll go out of full screen. Does that work? Oh, yes, thank God. OK, I'm back in the normal, known universe. Everything's fine now. I can stop panicking. Right, so if I just go back to this screen, it's given us lots of information about commands we can type next and what's happened under the covers. I'm just going to type this command, copy and paste it. What this command is going to do is, to the current terminal, it's going to output what's happening inside the pipeline. So what happens with Jenkins X is, whenever we push to the master branch, Jenkins X will create a new version number, a new semantic version number based on your source code. It will tag the Git repository. It will then run the release process. So it will create, in this case, it's Spring Boot. So it's going to make new versions of the, well, firstly, it's going to change the POM XML with the version number. So it's going to make 001. It's going to edit the POM. It's going to commit that into Git. It's going to tag it. Then it's going to build 001 of the POM XML and the jar and all that kind of stuff, chuck that into Nexus. Then it's going to make a Docker image with 001 of the jar inside it. Then it's going to push the image to the Docker registry. Then it's going to package up something called a Helm chart, which is the way of installing apps on Kubernetes. Then it's going to push the Helm chart into the Helm repository. Then it's going to start the promotion flow. So any moment now, if I go back to the Git repository, hopefully, we might have a release by now. Oh, OK, here we go. Let me make the window a bit bigger. Whoa, it's such a tiny cursor. If I click on releases, have we got a release yet? OK, so we've created the tag. So we've created the tag 001. In a few more moments, hopefully, the release will finish. The way we create the semantic version, we're using Git tags to figure out what the next version number should be. So if ever you want to go from 001 to 100, just create a tag, a Git tag in your Git repository, and the next release process will use a bigger number. We're hoping over time to improve this, to do things like contract validation or JSON schema validation or Java doc validation that goes, we're going to do a minor increment in your version number because we've detected a new API. You've got a new public API, so we bumped up a minor version. Or, oh my God, you broke your stuff, we're going to a major version. So we'd like to automate that much more, but for now, we're just using Git tags, so it's nice and simple. If I hit reload, we've now got the real release notes, so we've generated release notes 001. And if I click back on this window, we've now got 001 as a release. So we've got the Docker image, we've got the jars in Nexus, so we've done the physical release. Now we're starting the promotion flow. So notice this console output, it's got a pull request there. And if I can find where my crazy cursor's gone, there it is. And if I click on that, this is the pull request. So what we do is we generate a pull request on the Git repository for the staging environment. So the staging environment has got a little piece of YAML which has got all the applications it's running and which version. So if I look inside this pull request and look at the diff, now you don't need to worry too much about this. This is all completely implementation detail, but this is how it works. Can you read that? The Jenkins X has automatically added 3 lines of YAML into this YAML file. This YAML file is a standard Helm file. We haven't made this up. This is standard upstream Helm stuff. So what those 3 changes do is add this JW beer. I'm getting more thirsty every time I look at the project now. It's added JW beer as a new application, and it's saying run 001. Now, the next time we do another release, it's only going to have to change 1 line. It's going to go from 001 to 002. There's 3 lines in this pull request because we've never deployed this application before, right? Now, you can publish any application to any environment with this mechanism. Whether you built the application from source code or it's some upstream Helm chart that you found on the internet somewhere, we can use the same GitOps promotion model. It doesn't really matter who made the chart, right? Somebody else in your organization could make the chart, and you can use the same GitOps promotion model to promote other people's charts into your environments. So that's kind of chugging along. If I go back to the, I didn't mean to do that. If I go back to the pull request page, it's closed. So that means it's been merged. JWB has been merged. So what's really happened is we generate the pull request. That pull request on the environment has triggered a CI job. The CI job has validated, is that change valid for this environment? So was it a valid Helm chart? Was the Helm chart in the repository? Was the Docker image in the YAML in the Helm chart valid? And that was all green, so it's automatically merged. So now our pipeline is running in the staging environment to apply the results of that pipeline. So this might seem slightly overly complex, right? We're not just going straight to staging. We're generating a pull request. We're validating the pull request with a CI job. When that merges, we then run another pipeline to actually apply the contents. But what this means is we have a single way of doing promotions and changing config, and we're always going through CI. So we're always validating changes before they hit production, and we're always going through the pull request model. So depending on your team structure and your security rules and whatever, you can add different Git commit rules on those Git repositories. For example, it might be in the production Git repo, you insist on 3 people from the operations team have to plus one a merge before it can physically merge. Or you only allow people to merge to production when your image has been signed by the CV scanning tool or whatever. So people can add different kind of levels of CI testing around changes to environments. So we can use the same kind of CI and CD that we've always used for applications, but we can use them, in this case, for promotions into environments. Okay? So that was quite a lot of stuff in that very, very quick demo. We typed 1 command, and that created a brand new application from scratch. That application was then automatically promoted, released, and promoted, and it's just finished. It's just promoted to the staging environment. And it's showing me the URL of where that's running in the staging environment. And I can almost see my console. And if I click on that, there we go. That's the results. Now, that might look like an error, but that's actually the Hello World Spring. That's what Spring shows you when you don't write any code, right? So that's a working example. So I typed 1 command, and I created a new microservice, and through CI and CD, it's been promoted to the staging environment, which is kind of cool. Now let me show you how you actually start to develop. So if I go into this screen, CD into JWB. So this is the file system that we just created automatically. So I'm going to copy a magic file to source. Oh, I need a recursive copy. So I'm going to copy a magic file. Yeah, let me do git add source main resources, git status. So I'm going to do everything on the command line. So basically, I'm copying in a new home page to make this look more awesome. So let's create an issue. Create issue. -t add nice home page. So this is going to create an issue. In this case, we're using GitHub, but we support Jira as well. So we've created an issue on GitHub to track this issue, and I'm going to do a git commit. Or let's do a branch first. Git checkout -b changes. So I'm on a change branch, and I'm going to do a git commit. -a -m. Fix home page being a bit crap. And we'll say this fixes issue 1. So I've done a git commit. Now I'm going to do a git push. Now if I go back to my repo, by the way, a really handy command, if you sometimes forget where the web page is for your Git, you can type git repo, and it opens a browser with your Git URL of your app. So there we can see I've pushed some changes. Let me make this bigger. Ooh, it's a challenge with this big screen. I can do compare and create pull requests. I'm going to click this button to create a pull request. I could have done this from my IDE, but I thought I'd keep it real and keep it all command line. So there we go, we've created a pull request. So what's going to happen now is we've created the pull request. If I do jx get activity -w, we should get output of the pull request. You see the pull request pipeline has just started? So we automate CI and CD. So when you merge to the master branch, we generate a new release and we promote it through testing, staging, production. When you generate a pull request, we generate a pull request pipeline. And pull request pipelines are a little bit different. What the pull request pipeline does is what you might think of as CI. We'd run the tests, we compile the code, run the tests, check it all works. But we also do something slightly different. We create something called a preview environment. Now, Kubernetes has a thing called namespaces, and namespaces allow you to segment a Kubernetes cluster into logical clusters that are isolated from each other. So staging environment is one namespace, your production environment is one namespace, and a preview environment is another namespace. So all the apps in each of these namespaces can't see each other and don't interact with each other. This is kind of good because it means you can deploy things to staging and you don't accidentally see the production database. So whenever you're in a namespace, you only see the services in your namespace. You don't accidentally see the production database. So what we do when we create a preview environment is we create a brand new namespace just for the pull request. Then we're going to build the image. We're going to make a Docker image for the preview environment. Then we're going to push that to the Docker registry. Then we're going to boot up the application in the preview environment. So that basically means you get to test out all of your changes to all of your repos in their own separate environments before you merge. Right? Now, at first, that might sound a bit weird, but that means it's so much easier to review code. If ever you look at a code diff and there's HTML involved, or particularly CSS, it's almost impossible to review that and really know what is the effect of that code change on an end user. With preview environments, you get to click on the actual running app and see what the code looks like when it runs. Another thing about preview environments is it's really easy when you start using Docker containers and you start using Kubernetes, it's very easy to make an innocent-looking change with an environment variable, a port, a volume path or something, which means that your app actually dies and won't actually stay up for more than a millisecond or something. So even by having a preview environment that just starts it up and runs it for a while, you get like a really simple form of testing that checks, does my application still work? Does it start up? Does it run inside Kubernetes? One of the things we're really trying to promote with Jenkins X is we kind of want you, like, do you remember I wrote one command, right? I wrote one command and everything was then promoted to staging. What we really want to encourage developers is start by going straight to staging from day one, then write code in small increments. Another one of the State of DevOps report and the Accelerate Books thing is do small increments of code changes and keep testing continuously and keep deploying continuously. So don't sit in your ivory tower for 4 years writing loads and loads of code and then saying, let's see if it works on Kubernetes now, and it doesn't work and you can't remember when did you break it. run every small change in Kubernetes all the time. So the second the second you write some code that it stops working, you know what it is because it's a small delta, right? So another high-performing team thing is move in very small increments and just keep going quickly to production, right? So as you can see, by the way, if that pipeline just finished, if I go back to the pull request, there's the pull request. So have you seen this comment here? Pull request built and available in preview environment, and then there's a link, which I can find my minuscule cursor. There we go. If I click on that link, this is now going to test the application that's running in the preview environment. So here's the new homepage that I added to the app, right? So I've submitted a pull request, and I'm testing the running application with a pull request involved, so I can look at the application and try it out, and then go, this looks good to me, let's merge the change. Okay? So if I go back here and I go merge, oh, sorry, let me go back, this window. And if I go merge, I merge to master, and so because I've merged to master, within the next second or two, it's now going to trigger the next release, which is going to be 002, right? So then merge to master, we do a new release, and then that goes to staging. Pull requests, we create preview environments, you can test out changes. One other interesting thing about preview environments is often when you're working in a microservice kind of way, one team might be writing a back-end service, another team might be writing a front-end service or client that invokes the back-end. And you might want to do experiments where you say, could we add a new REST back-end that then a new front-end change can use? Both teams can work on a preview environment each, and the preview environment of the front-end can very easily talk to the preview environment of the back-end. Another common question we get asked a lot is, I like the preview thing, but how can I add other stuff? Like my front end needs a back end to talk to or needs a database. How can my preview have static data or a database or whatever? The preview environment is defined by something called a Helm chart, which you can add whatever dependencies you wish into your chart. So you can take the preview environment, add whatever backends you wish, and test whatever combination of charts you wish. Another thing you can do is you can service link your preview environment to other environments. For example, you can point the front end to the staging environment's back end for all the different back end microservices. So based on your team, you can figure out what's your ideal preview environment for each application in turn by just composing Helm charts and linking services. So a quick recap of all the demos so far. You type one command that creates a new microservice. You get CI and CD automated. You get automatic promotion to staging. There's one command to do the promotion to the production environment. And then preview environments are created on pull requests. So that's kind of cool. Just for the last few minutes, I just want to change tack slightly, if I can find my slides. I think that's it. OK. Present. Cool. I just wanted to talk a little bit about Jenkins X2. So Jenkins X is currently version 1 right now. And we're working on version 2 of Jenkins X, where we're making a couple of fairly significant architectural changes. Now, in good DevOps practice, we've put feature flags in place so we can keep developing the Jenkins X2 features while keeping Jenkins X1 rock solid, doing the normal things it does. Today with Jenkins X1, whenever you create a team, each team gets its own static Jenkins master that's always running all the time. So a normal Jenkins server, and all these pipelines run in the Jenkins master in the usual Jenkins way. What we want to do, though, is move Jenkins X into a completely serverless model so that you don't have to pay for lots and lots of Jenkins masters for lots and lots of teams if those teams aren't actually building any software. So we want to start moving Jenkins to be more of a serverless architecture where we only run Jenkins on demand when we need to do a build. So the first change in Jenkins X2, which is kind of confusing because X sounds like a version number. So think the X is like a product name. So Jenkins X2, the next version of Jenkins X, we're adding support for pluggable execution engines. So serverless Jenkins is one of the options in Jenkins 2. You can obviously stay with the classic Jenkins approach of having a Jenkins master per team. But we're liking the Jenkins X serverless model because it means you only run Jenkins, you run one Jenkins container to run each build, and then it disappears again, and then you've got a nice low footprint that's nice and cheap. We're using an open source project called a custom war packager from Oleg, which is really awesome, which basically makes a custom Docker image of a Jenkins job that just runs literally one pipeline and then terminates. So there's no Blue Ocean UI or anything like that. We just run the pipeline and then kill the pod, and everything's kind of good. We also have something called tillerless Helm. Helm 2 has a server-side component called tiller. Tiller is kind of a pain in the ass, quite frankly, and we all want it gone. And in Helm 3, which is hopefully going to come out soon, Helm 3 has no tiller component. To act as a band-aid until Helm 3 comes along, we've added support for tillerless Helm, which means there is no server-side Helm component. It effectively runs it locally on your local machine. Prow for webhooks is another huge change. Prow is an open source tool that came out of the Kubernetes ecosystem. And Prow provides a kind of a chat ops, chat kind of interface on pull requests. So for example, if you had an open source project, you probably don't want to run a CI and CD job on every pull request, because then people can come along and say, I'm just going to change your Jenkins file to email me all of your secrets and Bitcoin mine for a couple of hours. So you kind of want some kind of review process when a pull request comes in that says, is this pull request from someone I trust? Yes, it is. Approve the change. This is OK to test, right? So it gives you that command kind of interface where you can talk to the bot on the pull request in comments and then do things like start triggering a test because a pull request come from a non-committer, for example. What we're hoping to do is extend Prow some more so that we can do things like opt in or out of long-running soak tests and load tests, right? Some pull requests might come in and they're just a README change, so you don't worry too much about doing anything other than just unit tests. Other changes might be slightly more scary in nature, so you want to run complete soak tests and load tests to really, really test the crap out of the pull request before you agree to merge it. So Prow gives us that kind of conversational nature that we can discuss changes on the pull request before you agree to merge it. Another thing about Prow is a multi-tenant way of orchestrating build jobs. It's very small, it's very low overhead, and it's designed in a cloud-native way. So it's highly available, so you don't lose webhooks, right? There's a whole pool of pods running in Helm, in Prow, which will take webhooks in and convert them into Kubernetes resources so you don't lose webhooks. A common issue with Jenkins is often you might reload the Jenkins master because you've changed the plugin. The Jenkins stops listening to webhooks and you miss webhooks. So Prow's a nice Kubernetes native webhook handler. Finally, there's something called a promotion workflow engine. So today in Jenkins X1, when we do a release pipeline, we create the release, each new Docker image and Helm chart, and then we do the pull request on the staging environment, and then the pipeline currently waits for that pull request to go green and then merge. So we have lots of build pipelines sat there kind of waiting for stuff to happen, which, if you care about your cloud infrastructure bill, that's kind of suboptimal and a little bit of a waste of money. So with the new promotion workflow engine, what we basically do is terminate the build pods quickly. As soon as the release is done, the build terminates. And then we have this background process keeping track of all the different pull requests that are doing all the different promotions across all of the apps in all of the environments. So just one container takes care of the promotion of all of these apps. So rather than having lots and lots of build pods around for 3 weeks each, you can just have one very small, tiny little Go binary looking after all your promotions, which thanks to Kubernetes is highly available and is always running and so forth. So that's a quick sneak peek at what's coming in Jenkins 2. And this is the magic command line if you want to try out those features right now. So if you want to try out the 2.x version of what Jenkins X will look like, this is the magic command. Now, I will warn you, it's still quite early. Tillerless works great. The Prow thing, there might be some issues. So we're hoping to make this totally solid and totally awesome really, really soon. So if you like any of what you've heard today, and I hope you do, well, let's share a beverage in about 2 minutes' time. I'll just be outside drinking as soon as this is finished. Or was it that way? That way. So let's go and have a beverage together, and we can talk more about Jenkins X. Go to jenkins-x.io. There's tutorials on the website, there's videos, there's demos, there's articles. If you want to join the community, we're all on the Slack channel in the Kubernetes ecosystem. If you click on the community link, it tells you where the Slack channel is. Please give us feedback on Slack, on email, raise some issues on GitHub. And if you want to look at kubecd, there's a link on how to register interest in kubecd, which is basically an add-on to Jenkins X that gives you a really amazing front-end and management console and dashboard and so forth. So that's Jenkins X. Thank you for listening. Enjoy the conference.